Hello, hello, can you all hear me? At the back, give me a wave. Great stuff. Let's get into it. Imagine watching your favourite sporting event final. Millions of viewers simultaneously watching. Then, at that critical moment, the screen starts buffering. Live sports streaming represents one of the most demanding technical challenges in media today. Sports fans demand low latency and high quality. A goal should not be celebrated on social media before it is seen on your live stream. But delivering low latency streams at scale requires tremendous technical expertise. A primary feed drop during a championship match. A global outage of your content delivery network. These are not hypothetical scenarios. They are inevitable outcomes that demand robust failover systems. Do you stream 4K to everyone? It's a gold standard, but it may not be financially viable at scale. So do you sacrifice reach for quality? Do you dynamically adjust bit rates based on network conditions? Adaptive bitrate technologies require tremendous technical investment as well. My name is Colin Willis. I'm a solutions architect here at AWS, and I'm here with John Robbins from StreamAMG, and we are going to show you how to automatically provision and orchestrate sporting live streams at scale. Let's get started. Over the next 35 to 40 minutes, we will take you through how StreamAMG went from 1 to over 100 live streams. We will go deep into the architecture that made this happen, including some development practices, finishing with some key takeaways and best practices. Let's look at some data first. The entertainment industry breached the $1 trillion mark in 2024, and today's audience are sending us a clear message. We are facing an attention crisis. Our average audience attention spans are shrinking to that of a goldfish. Viewers want to participate, influence outcomes, and see themselves reflected in experiences. The future of entertainment isn't just watched, it's experienced, multidimensional, and more personalised than ever before. In 2024, digital sports viewership surpassed TV for the first time. Jake Paul versus Mike Tyson was streamed on Netflix, attracting over 108 million viewers. And out of 54 senior executives, 57% of them think that TV will be replaced by streaming services for sports. A quick show of hands, who here prefers to watch live sports via a streaming service? Interesting, it looks to be about 40%. Over 1,100 members of the public were asked how they prefer to watch live sports. Quite an even split in the results, isn't it? But what exactly is live streaming? Over the top, or OTT, is where media is delivered over the internet, bypassing traditional TV and satellite cable distribution mechanisms. And while pay TV and video on demand serve important functions, live sports primarily leverages live streaming. Live streaming provides minimal delay, broadcast quality, critical for those game-changing moments. AWS Cloud Infrastructure supports all of these use cases, delivering content to sports fans everywhere. AWS has a global footprint of 36 regions and 114 availability zones. You can instantly scale for major sporting events without needing to pre-provision infrastructure. The underlying architecture ensures continuous streaming, even during viewership spikes or technical issues, with multi-availability zone redundancy, keeping your content live. We have over 15 years transforming leading media and entertainment customers. A highlight this year so far is Tubi, Fox's LAX Super Bowl, the most streamed Super Bowl in history, with the audience average per minute of 13.6 million and a peak of 15.5 million. When building a sports streaming platform on AWS, you gain access to purpose-built infrastructure and services. Our engineering experts are continuously improving compression algorithms and streaming technologies. You can rapidly deploy workflows that can then integrate into the wider AWS ecosystem of storage, AI, and analytics. Perhaps most importantly though, you can you can enhance your monetization pathways, such as targeted advertising, subscription management, and consumption analytics to optimize those revenue streams. These purpose-built services are designed specifically for media and entertainment workloads. For content production, Elemental Media Live and appliances enable video processing and encoding of live video feeds. For supply chain and archive, MediaConvert and Amazon Simple Storage Service, S3, allow you to transform and preserve your valuable sports content. For direct-to-consumer streaming, which is the heart of this talk today, Elemental Media Package and Amazon CloudFront allow you to provide scalable streams to millions of viewers simultaneously. Finally, for monetization, MediaTailor provides personalized ad insertion without degradation of your quality. These integrated services are designed to power sports live streaming. Now I'm going to hand over to John from StreamAMG. He's going to take you through their journey and why they picked AWS.
Thanks, Colin. I'd like to introduce StreamAMG. We're a leading provider of online video solutions for sports rights holders and content owners. For over 20 years, we've been empowering sports organisations to deliver exceptional live and on-demand video experiences. Everything we do is focused on helping our customers achieve three key goals: increasing reach, growing revenue, and boosting engagement. And we do that by focusing on three value streams. First, content discovery, helping fans find and enjoy more from our clients' video-on-demand archives. Next, video operations and distribution. We provide an endless, end-to-end video workflow that provides high-quality live content to every device. And finally, monetization. We actively grow our customers' revenue using smart subscription management and targeted advertising. StreamAMG has a truly global reach, working with sports clients at every level, from lower league football clubs right through to top-tier sports federations. Sports organisations are recognising the untapped potential of their video rights and the power of OTT streaming. We're seeing a significant mindset shift from reliance on traditional broadcast to direct-to-fan delivery. Does anyone in the audience recognise some of these badges? These badges aren't just your favourite football clubs. Each of these badges represents a football club that trusts StreamAMG to deliver its live matchday streams directly to their fans. Fans today expect flawless viewing experiences, and there is absolutely no room for error. But the reality of live streaming is challenging, unpredictable, and high pressure. Live is live. There are no second takes, and we only get one chance to get it right. At StreamAMG, an incredible 95% of consumer bandwidth is dedicated to live events. This is where the fans are most engaged and where the expectations are the highest. We've navigated it all from network outages, stadium delays, and unexpected viewer surges. Because when fans miss a critical goal or the final whistle, they remember. Let's look at some of the key business challenges StreamAMG has faced. First, growth. Back in 2020, the pandemic forced clubs and federations behind closed doors. Overnight, streaming went from a nice to have to the only way to engage fans. We saw a significant mindset shift where our customers started to treat their streaming platform as a central part to their business strategy. Next, quality. Fans today expect broadcast level experiences, smooth high definition playback at ultra low latencies. With better devices and more accessible internet speeds, quality expectations are continually rising. Then cost. The OTT market is packed with competition. Our profit margins are tightening as our infrastructure costs are rising. And then finally, operations. We've evolved from managing just a handful of events to hundreds of concurrent live streams. Traditional manual workflows can no longer keep up with the demand. To effectively handle some of the challenges that we've just talked about, we identified 3 architectural priorities. First, efficiency, ensuring our streaming infrastructure delivers optimal performance without wasteful spending. Scaling our costs precisely with demand. Next, scalability, building a platform that can smoothly handle hundreds of concurrent live streams, not just for today's traffic, but for our future growth. And finally, reliability, guaranteeing robust, uninterrupted live streaming experiences so that the fans never miss those critical moments. As demand grew and our operational needs became increasingly more complex, we took a step back to evaluate where the industry was going and how we could best position ourselves for that future. We carefully researched and evaluated multiple options, ultimately choosing AWS, not just for its global scalability, but for its powerful tools, flexibility, and innovation that it would unlock. This next section dives into how we leveraged AWS to modernize our streaming infrastructure, simplify operations, and drive meaningful innovation. Before I hand back to Colin to go into a technical deep dive, I'd like to give you all a high-level look at what a modern live streaming media workflow looks like, end-to-end, or what we refer to as glass-to-glass. It starts at the venue, the stadiums, the courtsides, or any other live event location. This is where the action takes place. From there, cameras capture that live footage, sending it directly to an on-site encoder. The encoder's job is to digitize and compress that raw footage to make it stream ready. Next, the stream enters our transcoder. Here we take that single source and convert it into multiple renditions. This enhances device and network compatibility, and we refer to this as our bitrate ladder. After transcoding, we move into packaging. We wrap each of those renditions into delivery-friendly formats such as HLS and Dash so that they're ready to be sent out into the world. Then it's time for distribution. We distribute each of those package renditions via global content delivery networks, bringing the content as close as we can to the users to lower latency and maximize reliability. And then finally, it hits your devices, your smart TVs at home, or the mobile devices that you've brought today, wherever you decide to watch. Every step in this workflow has to be seamless. If any point fails, the fan experience suffers. And that's exactly why we needed a platform that's both reliable and flexible at scale. So I'll hand back over to Colin to talk you through how we architected this on AWS.
Thanks, John. I just love the glass-to-glass phrase. So I'll take you through a couple of what we see as our top 2 AWS services for live streaming, and then we'll dive into the architecture of what StreamMG built. The first service is AWS Elemental Media Live. It's a broadcast-grade video processing service that encodes and compresses live video feeds. It's built on technology proven by global broadcasters, and it supports features such as ad markers, closed captions, and FCC-mandated loudness correction. Media Live supports industry protocol standards such as H.264, H.265, and AV1, streaming protocols like RTP, RTMP, and HLS, as well as Dolby Vision and HDR10. With just a few clicks, you can provision and deploy fully configured live channels where the scaling, monitoring, and reporting is handled for you. Reliability is also built in with automatic replacement of failed resources. The next service is Amazon CloudFront, our content delivery network. CloudFront accelerates static and dynamic content via AWS's global edge network. Edge locations cache content closer to the user, providing smooth experiences with minimal buffering. Your sports content stays protected with integrations to AWS WAF for application level protection and Shield for DDoS mitigation, crucial for those high-profile sporting events that may be targeted. Finally, you can run serverless compute functions at the edge, customizing user experiences such as routing around unhealthy endpoints. CloudFront helps reduce costs via zero transfer fees from AWS origins. With over 700 locations strategically positioned near high populous areas, your content will be closest to your users. Notice how each edge location connects back to an AWS region via AWS's private, redundant network backbone. This architecture is purpose-built for performance. MediaLive and CloudFront are great for live streaming, and hooking them together is straightforward as well. AWS provides 2 reference architectures on the solutions library. These are ready to deploy, open source, and available on GitHub. If you're not able to get the QR code, you can see me afterwards. I'll be over by the AWS sign. So what did StreamAMG do to go from 1 to over 100 concurrent live streams and to provide that 24/7 video operation? Well, they built a platform called Orchestrate that allows them to manage cloud infrastructure on demand. This is the Orchestrate platform high-level architecture. It's used by StreamAMG video operations engineers. The UI is underpinned by microservices and event-driven architectures that then control the live video processing services you see here. StreamAMG operations engineers perform various actions such as schedule upcoming live event, updating MediaLive configuration, updating CloudFront URL, etc. Let's step through this architecture now in more detail. First, a bespoke user interface was developed. It's a React single-page application that's statically hosted on S3, fronted by CloudFront. S3 is a serverless object store that provides 11 nines data durability and 4 nines availability by default. Different versions of the single-page application are deployed to S3, and then when a new version is released, CloudFront is updated to reference that new version. Amazon Cognito provides secure authentication to your application. It's a developer-centric service that allows you to add sign-up, sign-in, and access controls to your app. StreamAMG chose this because they wanted a cost-effective access management system that would integrate into the wider AWS ecosystem of services. A microservices architecture with RESTful APIs supports the user actions from the user interface. Amazon API Gateway hosts these APIs. API Gateway is a fully managed API service allowing you to create and publish APIs at any scale. AWS Lambda is a serverless compute service allowing you to run code without needing to provision infrastructure or servers. With these 2 services, StreamAMG adopted a serverless microservices architecture where each component is decoupled and independently deployed and operated. For storage, both S3 and Amazon Relational Database services are used. One action of the live operator is to upload a MediaLive configuration file. It's a JSON file and quite a big one at that. S3 is perfect for this because you can store the JSON file directly as it is without needing to transform it into a database format. RDS is an easy-to-manage database service with push-button scalability. RDS is used to store the data relationship mappings between end clients and these configurations that are stored in S3. For example, an operator may assign a specific MediaLive configuration to a specific football club. To summarize, the user interface is supported by a microservices architecture, all of which are synchronous interactions so far. Until we add in some event-driven architecture, of course. One of the main use cases of the live operator is to schedule an upcoming event, meaning that some system activity needs to occur in the future. An event-driven architecture is ideal for this, and using serverless makes it highly cost-effective because you only pay for the services when they are being used. Amazon EventBridge is a serverless event bus that receives, routes, and delivers events. It's also got a built-in scheduler to trigger events. Amazon Simple Queue Service, or SQS, is a serverless message queue, allowing you to send, store, and receive messages between software components. Using these two services together, and Lambda for processing, you end up with an event-driven queue processor. To summarize, EventBridge can be used as a listener or as a scheduler to drop messages onto the SQS queue, which are then picked up by Lambda to do whatever you need to do. The queue processing Lambda uses the AWS SDK to provision and orchestrate the live video processing services you see here. An example event that may come off EventBridge is something like provision live infrastructure, update media live channel, update CloudFront URL. The live video processing services are deployed or provisioned on a per sport, per event basis in the region where that sporting event is happening. I've already spoke about Media Live and CloudFront, but I haven't mentioned Media Package yet. AWS Elemental Media Package packages video streams into different distribution formats, such as MPEG-Dash, HLS, or CMAF. It's also got a digital rights management capability built in. But provisioning resources on demand takes time, usually minutes. So what does the live operator do here? What does he see? How does he know? This is where state changes for those provisioned services are piped back to the event-driven architecture. EventBridge picks up these state changes and updates the RDS, but it also pipes them directly back to the user interface of the operator via API Gateway's WebSockets capability. So now we have the end-to-end architecture. Let's walk through an end-to-end scenario. A live operator logs in securely to the UI and decides that they want to schedule a football match for this Saturday. Let's say Leeds United in the Premier League. So the live operator will select the pre-existing configurations for Leeds United and create the schedule, 2:30 kickoff or 3 PM kickoff, 2:30 resource provisioning. When 2:30 on Saturday comes along, EventBridge will wake up, drop an event onto the SQS queue. That will be picked up by Lambda. Lambda will look in the RDS to find those configuration mappings that are in S3, and then on demand, spin up a Media Live, a Media Package, and a CloudFront. While those services are coming online, state changes are pinged to the EventBridge. The live operator gets a real-time view of the status of all of those services coming up. After the event, hopefully Leeds have won, those live video processing services can be stopped or destroyed. A key architectural call out here is that the event-driven architecture decouples the user interface and the microservices from the live video processing services. That means that one live operator can schedule and orchestrate hundreds of live streams within minutes. And this is what the operator sees and uses. Note that this is not the AWS console. The Cloudscape design system is used here. It's a UI framework developed by and used by AWS. And yes, the AWS console uses this same UI framework. StreamAMG chose this framework because they wanted to quickly develop a user interface with tested and accessible UI components. From this one screen, an operator gets a multi-regional view, a multi-client view, and a multi-sport view of all of the events that they need to operate. Now it's time to look at some code, some design decisions and best practices to make all of this happen.
Once we had our high-level architecture in place, the next steps were clear. Understanding how we can further leverage AWS's powerful tools to build out our application in practice. Let's dive into some of the key design decisions that we made along the way and how these decisions helped us fully harness AWS to deliver a robust and reliable streaming platform. Instead of adopting traditional infrastructure as code tools such as Terraform and CloudFormation to manage our media infrastructure, we chose a more dynamic approach by using AWS software development kits directly. This decision was driven by the sheer amount of infrastructure changes that we would make on a daily basis. Managing this level of change with using static infrastructure as code templates would have added significant complexity and slowed us down. By using AWS SDKs, provisioning is triggered dynamically by application events. Resources are spun up exactly when needed and torn down when not in use, significantly improving cost efficiency. As you can see in this code example, it's straightforward. With just a few lines of code, we dynamically load JSON configurations from S3 and provision complex AWS resources like Media Live channels in real time. Next up is the EventBridge scheduler. Scheduled jobs are essential to our platform, whether it's starting a channel, cleaning up resources, or triggering an automated workflow. Traditionally, this meant building and maintaining our own schedulers using cron jobs, which meant the introduction of more static infrastructure, more complexity, and more operational overhead. With AWS EventBridge Scheduler, all of that goes away. It's a fully managed serverless scheduler, which means no infrastructure to provision, no patching, and no scalability concerns. Even better, we can define and manage all of our schedules within inside our application. As you can see in this example, how we schedule a Lambda to be called at 2:30 every Saturday. It provides us with built-in retries, high availability, and deep integrations across a number of AWS services. But most importantly, it gives us the confidence to run mission-critical schedules at scale. To bring consistency to our stack, we adopted AWS Cloud Development Kit as our application infrastructure as code framework. AWS CDK is an open source software development framework that allows you to define infrastructure as code and provision it via CloudFormation. One of the biggest benefits is that we define everything in TypeScript, the same languages that we use across our front-end and back-end applications, and now our infrastructure. CDK also gives us first-class support for serverless and event-driven architectures to support the designs that Colin previously talked us through. In this example here, you can see with just a few constructs how we can define the infrastructure to set up our EventBridge rules to listen for Media Live events. Another big win for us all is that CDK evolves with AWS. As new services and features are released, a team at AWS is building on our dependencies so that we don't have to look after outdated modules. To round up our infrastructure strategy, we also adopted CDK pipelines. This allowed us to define AWS code pipeline CI/CD workflows directly alongside our code base. This means that the complete deployment process utilizes the same languages and frameworks as the rest of our application stack. Teams can ship with confidence, knowing the build, validation, and deployment steps are all run on repeatable and consistent managed CI/CD infrastructure provisioned by AWS. As you can see in this snippet, everything from build to deploy is defined in a simple construct. This approach helped us move fast, stay reliable, and scale our engineering practices alongside our platform. So this is what it looks like in action. Our end-to-end CI/CD workflow built on AWS tools. So let's talk through some of these tools now. AWS Code Pipeline is a continuous delivery service that allows you to model, visualize, and automate the steps required to release your software. We use AWS Code Pipeline to orchestrate our build and deploy processes using AWS Code Build. AWS Code Build is a fully managed build service that allows you to perform deployment tasks as seen here. But this pipeline wasn't just about automation for us, it was about impact. With this setup, we managed to significantly improve two of our core DORA metrics: deployment frequency and lead time for changes. We went from releasing every couple of weeks to multiple times a day, and our lead time for change went from days to hours. So that covers some of our design decisions. So to wrap up from me, here's a snapshot of what we've achieved so far. We've orchestrated over 20,000 live events across 113 of our clients. Behind the scenes, it means that we're managing 392 channels and nearly 600 inputs. Operationally, we've saved over 850 hours, but most impressively, we've managed to save $150,000 from dynamically managing configurations to avoid idle resource charges. These results reflect the power of combining the right tools, the right mindset, and the flexibility of AWS to scale and innovate.
Loving the numbers. Nobody likes to pay for idle infrastructure, right? So as we finish off, now we're up to the key takeaways. Building the Orchestrate platform has been a journey. And these are probably the top lessons learned and key takeaways that we'd like to share. First, pick the architecture and AWS services to match your workload requirements. Use AWS decision guides and reference architectures that are available to you. Use infrastructure as code where applicable, but consider your infrastructure after it has been deployed. Maximize AWS managed services. This reduces your operational overhead, and serverless reduces them even more. StreamAMG doubled down on this and reaped the rewards from it. Be a frugal architect. Deliver simple systems that are adaptable to business and technical challenges when they arrive. And lastly, the AWS well-architected framework. It describes key design principles and best practices. There are 6 pillars, and the operational excellence pillar is one I personally recommend to give you the best bang for buck with guidance and remediations for risk items. Hopefully this talk has inspired you to go build and help your business grow. And with that, we have Skill Builder. There's over 600 free digital courses, hands-on labs and role-based games. Thank you all for your time today. Hope you've had a great summit. And John and I will be over by the AWS Summit sign if any of you want to chat. Thank you very much. And yeah, please do the QR codes. Get us to reinvent. Still a bit fast.